guys, welcome back to the channel. Jag here, and in today's class we're going to continue with our Math 11 content. What we're covering today is going to be the maximum and the minimum values of a quadratic function, okay? And what we're going to use is completing the square method in order to find the answer, all right? And again, make sure you have your calculator handy as you're doing these questions. Okay, so we're going to start off with really simple questions first, and then maybe we can try one of the harder ones, all right? So let's try this example. All right, so the question says determine the maximum or minimum value. Okay, so let's try this equation. It's y equals x squared minus 4x, okay, and minus 1. Okay, so if I have like an equation, a quadratic equation like this, the fastest way to find the maximum or minimum value is by completing the square, okay? So let's try this method first. I'm going to put brackets around the two first terms. I'm going to take the middle term, which is the 4, and I'm going to divide it by 2. And this is actually the perfect square. And again, remember, I see a negative sign in front of the 4x here. I'm not going to use the negative sign. It's not going to make a difference, okay? So the perfect square here is 2. We're going to add and subtract the perfect square, okay? So brackets, x squared minus 4x, okay, plus 2 squared, minus 2 squared, close the bracket, minus 1. All right, does everyone see that? So we're just adding and subtracting the perfect square. And one more time, what you notice is that it doesn't actually change the quadratic function itself, okay? Because I'm adding and subtracting the square of the same number, all right? So in the next step, what we're going to do is take out this negative 2 squared and take it outside of the brackets. So I'm left with x squared minus 4x. And we're just going to put the 2 squared here, which is equal to 4. Again, remember it's 2 times 2. Okay? And the negative 2 squared, which is negative 4, I'm going to take that outside the brackets. So outside we have negative 4 minus 1. Okay, everyone sees that so far? And in this final step, actually, what we're going to do is just combine a couple of the steps together. So I'm going to put y equals x minus, and I know I'm using the negative sign here because this first sign inside the bracket is also negative, okay? So it's going to be x minus 2, which is my perfect square, which we have right here on this side. And it's going to be squared. And outside the brackets, I have negative 4 minus 1, which is negative 5. Okay? Does everyone see how to do that? Okay, and here it just says to state the maximum or minimum value. So I'm going to show you, without actually like sketching out a graph or anything like that, how you can tell whether it's a maximum or minimum value. Okay? So now this is my final answer. Let's box it. Okay? And the reason I'm boxing it is just to show you in front of the brackets here, there is no negative sign, okay? So I actually know that my parabola is opening upwards. So we'll put upwards like this, okay? Whenever the parabola is opening upwards, I see that basically what I have here is a minimum value, okay? So we'll put minimum value, okay? And what we're going to use, let's write the vertex out here, okay? So everyone can see it. Again, remember when you complete the square, it just gives you the vertex form of the parabola. All right, and the vertex here is going to be positive 2 and negative 5. Okay, so let me write it a little bit higher. So positive 2, negative 5, okay? This is the vertex right here. Remember, inside the brackets, I have x minus 2. So for the x point of the vertex, you do have to change the sign. And that's why I changed it to positive 2 here, okay? And outside the bracket is negative 5. I don't need to change this sign, okay? So our vertex here is going to be positive 2 and negative 5, okay? I know it is a minimum value because the parabola is opening upwards, all right? And the minimum value occurs at the y point of the vertex, okay? So I'm just going to write minimum value at negative 5. All right, does everyone see that? And that's all you need to do. I don't actually even have to graph or even sketch a graph, okay, of this quadratic function. I can just tell you right away whether or not there is a minimum or maximum value and exactly where that minimum or maximum value occurs. All right, so with that, let's try another example. That looks good. All right, I'm going to take this off. Okay, we're going to do the same type of question. Okay, we are going to find the minimum or the maximum, okay, of this function. And again, as you're looking through the textbook, you'll notice that there are a lot of application questions within this section. Try to do a good portion of these questions so you get really good at this, okay? So let's try this one. Okay, so it says f of x here is equal to x squared minus 8x, okay, and plus 12. Okay, so again, I can see that I have this quadratic function. It is a trinomial, all right? And we are just going to determine the maximum or the minimum values here, okay? So in this question, actually, it does say use at least 2 different methods, okay? So for the first example, we did complete the square, okay? This time, let's try doing a different method. And the second method we can do is basically factoring. So I'm going to put factoring this out, okay? Because this is a simple trinomial, I could just do the sum and product here. So let's do that. So the product is equal to 12, I'll put positive, so positive 12, which is that last number, and the sum is always the middle number that is in front of the x value, okay? So the sum of these two numbers that you come up with has to equal to negative 8. When you multiply the two numbers, it has to be positive 12, okay? So what we could do is 6 times 2, which is 12. Okay, when I add them together, it has to equal to negative 8. And the only way to do that is if both of these numbers are negative. So I'm going to put negative 6, negative 2. So if you do negative 6 plus negative 2, that is equal to negative 8. Okay, so I can see that both of the conditions have been satisfied here. And my two factors are going to be negative 6 and negative 2. Okay, one more time, because this is a simple trinomial, I don't need to really show my work. I'm just going to write out my factors. So I'm going to put x minus 6 and x minus 2. Okay, so these are my two factors here. Okay, I do have to look for the max or the min value. So when you are doing the factoring method, you have to do several different steps. And that's why, like I said before, completing the square is actually the fastest way to find the maximum or minimum value. Okay, but let's still do this method because the textbook is telling you to use 2 different methods. Okay, I'm going to make my quadratic function equal to 0. So at the same time, I'm looking for my x-intercept. So I'm going to do x minus 6 equals 0. And then take this negative 6 to the other side. So x is equal to 6. Everyone sees that? Okay. And the second one we're going to do is x minus 2 equals 0. And then the same thing, take the negative 2 to the other side. Every time you go across the equal sign, make sure you are changing the sign. So it's going to be x equals to positive 2. Alright, so we have to remember that we are actually not done here, okay? All we did here is find the x-intercepts, and I'm still looking for the vertex, okay? So I'm going to take off part of this question here, okay? And when you're looking for the vertex again, okay, so I'll put vertex on the top here. Okay, let's make a line. We'll keep it separate here. Okay, I have to look for the x and the y point of the vertex. Again, remember the maximum or minimum value occurs at the y point of the vertex. So I have to solve for both of the values here. So I'm going to put Vx. When you're looking for the x point of the vertex, okay, the best way to do this, there is an equation, okay? However, I just remember to add the x-intercepts together. So we're doing 6 plus 2. And then you divide it by 2, okay? And again, don't worry if you do get any decimal values. That doesn't matter, okay? And it's important that if it is a decimal, you're using the decimal value, especially if you need to graph out the quadratic function. Okay, that's the only way to do it. Make sure you're rounding all the decimals to 1 decimal place here, okay? So the nearest 10th. Okay, so here we are doing 6 plus 2, so 8 divided by 2. And the x point of the vertex is equal to 4. Okay, does everyone see that? Let's circle it. And then we're going to find, again, the y point of the vertex. How you find the y point is you're going to take the x point of the vertex, we're plugging it back into the original equation. Okay, So this is our original equation right here. So I'm going to write it out one more time. So x squared minus 8x plus 12. What we are plugging in into the x value is the 4 that we solved for here, okay? So I'm going to put 4 squared minus 8 times 4 plus 12, okay? And this is enough actually for you to find the final answer. So I'll put 16 minus 32 plus 12, okay? And we'll just write it on one line here. And again, it does not matter if you don't want to show this one step here. It's not that big of a deal. And we're getting negative 4. So I can see when we're using, again, this method here for factoring, it does take a little bit longer, okay? Even if I completed the square here, I will get the same answer for the vertex. All right, so I'm going to put the vertex here on the bottom. Okay, so the vertex is going to equal to 4 and negative 4. All right, so again, the question was asking whether or not this is a maximum or a minimum value. Okay, so I'm going to take off this on the side here. So we're doing the factoring method. Okay, let's keep the x-intercepts there so everyone can see it. Okay, so again, after I did factor it, I noticed that there's no negative sign in front of the x squared here. So I know that the parabola is opening upwards. So every time it's actually opening upwards, you see like a small dip. And this dip basically means it's a minimum that is happening. So I'm going to put minimum at, and where does the minimum occur, guys? Again, the y point of the vertex, okay? The y point we got here was negative 4, okay? And we're putting minimum at negative 4, all right? Now say there was a negative sign in front of the x squared, okay? In that case, the parabola would be opening downwards. And if you see like a hilltop like this, okay? This would be a maximum value. Okay, and basically again, the maximum value would also occur at the y point of the vertex. Okay, so you can see that I do have to solve for the vertex depending on whichever method I use. Okay, I have seen questions here where the teacher is asking students to find the maximum or minimum value using even 3 methods. Okay, so let's just go through the 3 types of methods that you can use. All right, so the first method that we did was completing the square, and that changes the standard form of the quadratic into the vertex form. All right, and again, that's the best way I can find the vertex right away, and I have the y point of the vertex, and I'm just looking for that negative sign, okay, in front of the quadratic function. And if you don't see that negative sign, the parabola is opening upwards and is going to be a minimum value, okay? However, if there is a negative sign in front of this quadratic function, then you know that the parabola is opening downwards, and in that case, there's going to be a maximum value, okay? Or a maximum at basically whatever the y point of the vertex is, all right? That is the first way to find the maximum or minimum value of the quadratic function. We did completing the square. And the second method we did over here on the board was basically just factoring out the quadratic, okay? We did the sum and product because this was a simple trinomial, all right? I was able to factor it right away and get the 2 x-intercepts, and then I had to actually find the x point of the vertex and the y point of the vertex separately, okay? So a little bit more work here when you are doing the factoring method, but that's okay. You will still get the same answer, okay? And lastly, the third way to actually find the maximum or minimum value would be like you're using the quadratic formula, okay? So if you were to use, so I'm going to put it on the board here, okay? If you were to use the quadratic formula, what this would actually give you would be basically the same thing. It would give you the x points of the vertex, but it is still seen as a different method to find the x-intercepts. And I would actually have to do this method one more time. Even if I was using the quadratic formula, I would have to use that method to find the vertex, okay, of the quadratic. And that would be the only way that I can solve it. All right? Okay. So if there are no questions, that brings this video to an end. Thank you for watching. Please make sure you do like, share, and subscribe to the channel. And I will see everyone in the next video. Thanks. Bye.